Welcome to the Pure AI Podcast, where we unpack the latest in artificial intelligence, tech innovation, and whatever else the machines are cooking up this week. I'm John K. Waters, Editor-in-Chief in the Converge 360 group at 1105 Media.
And I'm Gladys Rama, Editorial Director. We're back with another episode loaded with breakthroughs, buzzwords, and a healthy dose of human perspective. Because, yes, we still do the thinking around here mostly. As always, our team of real journalists did the digging. AI just showed up at the end to take a bow.
Today we have three fascinating stories that showcase just how rapidly the AI landscape is evolving. First, we'll dive into Meta's ambitious launch of their Llama 4 suite of AI models, which represents a significant challenge to competitors like OpenAI, Google, and xAI.
Then we'll explore IBM's strategic acquisition of Hakkoda, a global consultancy specializing in data modernization and AI.
And finally, we'll examine the findings from Stanford University's AI Index Report 2025, which reveals both the explosive growth in AI adoption and some concerning gaps in regulation and equitable access.
It's a packed episode that highlights the multifaceted nature of today's AI ecosystem, from cutting-edge models to corporate strategy to the broader societal impact. Let's get started.
Let's begin with Meta's big announcement. This week, Meta Platforms unveiled a new suite of AI models under its Llama 4 banner, marking a significant expansion of its capabilities in generative artificial intelligence. This move represents a direct challenge to industry leaders like OpenAI, Google, and Elon Musk's xAI.
This seems like a major step forward for Meta. What exactly are they bringing to the table with these new models?
Meta has introduced four distinct AI models in this release: Llama Scout, Maverick, Behemoth, and Reasoning. Each is designed for different computational needs and applications. What's particularly notable is the substantial increase in parameter size compared to their previous Llama 3 generation, along with new efficiency mechanisms that Meta claims deliver best-in-class performance.
Parameter size is often used as a measure of an AI model's potential capabilities. How do these new models stack up against the competition?
The parameter count represents more than a twofold increase over Meta's previous generation. According to Meta's content and social media manager, Andrew Hutchinson, these models are specifically designed to offer various options that can run on systems with different levels of computing power.
So developers could potentially choose which model best fits their infrastructure requirements?
Exactly. For example, Llama Scout, which is the smallest of the models, can run on a single GPU, making it accessible to smaller teams or organizations without massive computing resources. At the other end of the spectrum, Meta claims their Llama 4 Behemoth model has more than 2 trillion parameters, potentially making it the largest publicly available AI model in the world. Let's dive deeper into these four new Llama models. Meta has differentiated them for specific use cases and computational requirements. Starting with the smaller models, can you break down what makes each one unique, Gladys?
Absolutely. Llama 4 Scout and Maverick are the more accessible models in the lineup, both equipped with 17 billion parameters. What's interesting is that despite their relatively modest size, they're designed to be remarkably efficient. They can actually run on a single GPU, which makes them far more accessible to smaller organizations and individual developers.
That's an important point about democratizing AI. These models use what's called a mixture of experts system, right? Can you explain what that means?
Sure thing. The mixture of experts approach is clever. Instead of activating the entire model for every query, it only activates specific subsets of model parameters depending on what's needed. This dramatically reduces latency and compute requirements without sacrificing accuracy. It's like having specialized experts that only weigh in when their particular expertise is needed.
And then at the high end, we have the massive Llama 4 Behemoth model with its 2 trillion parameters. That's an absolute monster in terms of scale.
It truly is. For context, that's more than a twofold increase over Meta's previous Llama 3 generation. Meta is positioning Behemoth as the largest publicly available AI model in the world, which is quite a statement considering the competition out there.
They're not revealing as much about the fourth model, though, Llama 4, reasoning. From what we understand, it's specifically designed for complex inference and decision making tasks, but details remain sparse on its exact capabilities and parameter count.
It's worth noting how Meta's approach differs from competitors. While OpenAI and others keep their models behind APIs, Meta is building in more system logic to dig deeper into context. As Hutchinson noted, they're designed to ask more questions and explore context more thoroughly over time.
Comparing these to previous generations, the jump in capabilities is substantial. The parameter count is one thing, but it's also about how efficiently these models can process information and generate responses. The architecture improvements suggest Meta has been working hard to catch up with and potentially surpass industry leaders.
And all of this comes at a time when the AI race is really heating up. OpenAI is reportedly working on GPT-5, Google continues expanding its Gemini lineup, and everyone is chasing that next breakthrough in performance and efficiency.
Exactly. It's fascinating how quickly the field is evolving. Just a year ago, a 17 billion parameter model that could run on a single GPU with this level of performance would have seemed remarkable. And now, it's just the entry point in Meta's lineup. Behind these impressive Llama models is a massive hardware investment that sets Meta apart in the AI race. They're now operating approximately 350,000 NVIDIA H100 chips. That's a staggering number.
And that number becomes even more significant when you compare it to their competitors. From what we understand, OpenAI is using around 200,000 of these chips, and Elon Musk's XAI is in a similar ballpark. Meta has substantially outpaced them in pure computational firepower.
Meta is also accelerating development of its own AI chips to reduce the company's dependency on third party suppliers like NVIDIA. That vertical integration could give them a significant cost advantage down the road.
As Andrew Hutchinson noted in Meta's blog post, in terms of tangible, available compute and resources, Meta is pretty clearly in the lead. That computational dominance positions them to handle high volume AI workloads more efficiently, both for their own applications and potentially for external partners.
What really stands out to me about Meta's approach is the company's decision to open source all of these Llama 4 models. That's a fundamentally different strategy from what we're seeing from OpenAI or Google.
By making these models available to third party developers, they're essentially seeding the ecosystem with their technology. We're already seeing major platforms like LinkedIn and Pinterest integrating Llama models into their systems.
And as Hutchinson pointed out, external developers using Meta's models stand to make Meta the key load bearing foundation for many AI projects. That's the long game here, becoming the infrastructure that others build upon.
Exactly. While OpenAI and others are charging premium rates for access to their models through APIs, Meta is building influence and market share through this open approach. It's similar to what we saw with Android versus iOS in the mobile space.
The business implications are significant too. All those Meta products, WhatsApp, Facebook, Instagram, Messenger, they're going to integrate these improved models in the coming weeks. That affects billions of users and could substantially improve the user experience across their platforms.
Not to mention their advertising infrastructure, which is still Meta's primary revenue engine. These models will power smarter targeting and content generation for advertisers. That's where the immediate financial returns will likely come from.
There is some healthy skepticism about Meta's performance claims, though. Hutchinson acknowledged that some observers have questioned the transparency and applicability of their internal benchmarks.
That's true of most AI companies' claims these days. The real test will be when these models are deployed in the wild and developers start pushing their limits. But Meta's pitch that Llama 4 delivers superior results at lower cost is going to be very appealing to developers facing tight compute budgets.
Let's talk about what these new Llama 4 models actually mean for Meta's product ecosystem. They've got this massive family of apps, WhatsApp, Facebook, Instagram, Messenger, that billions of people use every day.
Right, and Meta has confirmed that these models will be integrated across their entire product suite in the coming weeks. The most visible impact will likely be in their chatbot experiences. Users should notice more coherent, contextually aware responses when interacting with AI assistants.
I think content generation is where we'll see some of the biggest improvements. Llama 4, Behemoth with its massive 2 trillion parameters should be capable of creating much more nuanced, creative content for users and businesses within Meta's ecosystem.
And let's not forget that Meta has been gradually introducing AI generated elements into their platforms already. With Llama 4, they can expand these offerings. Everything from AI generated image backgrounds to more sophisticated text generation tools for businesses using their platforms. Shifting gears now, let's move on to our second story. IBM has made a significant move in the AI space with its acquisition of Hakkoda Inc., a global consultancy specializing in data modernization and artificial intelligence. The deal was finalized on April 2nd, though the financial terms weren't disclosed.
This is a strategic acquisition for IBM, clearly. To put it in context, Hakkoda brings hundreds of certified experts in cloud based data platforms to IBM's already substantial consulting arm. They're particularly known for their expertise as an elite Snowflake partner with numerous awards and certifications in that ecosystem.
And timing wise, this couldn't be more relevant. As we've just discussed with Meta's new models, the AI landscape is evolving rapidly, but there's a critical step before most enterprises can even begin to leverage these advanced AI capabilities, and that's data modernization.
Exactly. IBM clearly recognizes that many organizations are struggling with the foundational work needed to deploy generative AI at scale. You can have access to the most powerful AI models in the world, but if your data infrastructure isn't properly modernized and organized, you simply can't maximize their potential.
What strikes me about this acquisition is how it fits into IBM's broader strategy. They've been methodically building out their AI consulting capabilities through a series of strategic acquisitions. This seems to be another piece of that puzzle, specifically targeting the data preparation side.
And they're focusing on some key sectors with this move: financial services, healthcare, life sciences, and the public sector. These are all data intensive industries with complex regulatory requirements where IBM already has a strong presence. AI.
What makes this acquisition especially significant is how it aligns with the current state of enterprise AI adoption. Many companies want to implement AI solutions, but are struggling with the fundamental data infrastructure needed to support them.
That's right, Gladys. I've been covering IBM for years, and this fits perfectly into their broader AI strategy. They've been positioning themselves as trusted partners for businesses that need end to end AI solutions, not just the models themselves. This acquisition bolsters what they call their AI delivery platform, IBM Consulting Advantage.
And Hakoda's CEO, Eric Duffield, specifically mentioned joining IBM at this critical moment when organizations are looking for a trusted partner to help them modernize their data for the AI era. It's clear both companies see this as a timely move.
IBM's senior VP Mohammed Ali emphasized that Hakoda's expertise and asset centric delivery model will help IBM deliver value faster to clients transforming with AI. With Hakoda's global presence across the US, Latin America, India, Europe, and the UK, this significantly expands IBM's reach.
And it's worth noting that Hakoda also holds advanced tier partnership status with Amazon Web Services. So this isn't just about Snowflake expertise. It's about comprehensive data modernization capabilities across multiple cloud platforms.
It's also worth underscoring Hakoda's specialized expertise. They've received multiple accolades from Snowflake, including being named the 2024 Healthcare and Life Sciences Services Partner of the Year. That kind of specialized domain knowledge is incredibly valuable when you're dealing with complex, regulated industries.
And those industries often have the most challenging data environments, don't they? Years of legacy systems, siloed information, regulatory constraints, all of which need to be addressed before meaningful AI implementation can happen.
Absolutely. What Hakoda brings to the table is the ability to migrate, modernize, and monetize enterprise data platforms. They've built their entire business model around preparing data estates for the AI era. And IBM clearly views this as critical groundwork for deploying generative AI at scale. Let's talk about the broader market implications of this acquisition. IDC's projections for the enterprise intelligence services market are quite striking, from $169 billion in 2025 to $243 billion by 2028. That's a massive opportunity IBM is positioning itself to capitalize on.
This fits perfectly into IBM's long term strategy. For years now, they've been methodically building their hybrid cloud and AI consulting business through strategic acquisitions. Hakkoda is just the latest piece of that puzzle.
Exactly. IBM Consulting is increasingly becoming a powerhouse in this space. When you look at their IBM Consulting Advantage platform, which is their AI delivery platform, adding Hakkoda's capabilities makes it substantially more competitive, especially since data readiness is often the biggest bottleneck in enterprise AI deployments.
Overall, this acquisition makes IBM a much more formidable competitor in what's shaping up to be one of the hottest growth markets in tech. The race to help enterprises transform with AI is accelerating, and IBM just significantly upgraded their position.
Now let's move on to our third story of the day. Stanford University's Institute for Human-Centered Artificial Intelligence has released their latest AI Index report for 2025.
This report is the gold standard when it comes to understanding the global AI landscape. It's now in its eighth edition, and what makes it so valuable is how comprehensive it is, covering everything from technical progress to economic impact to societal implications.
Exactly. What struck me immediately about this year's report is the sheer scale of AI adoption we're seeing. The report's co-directors, Yolanda Gill and Raymond Perot, put it well when they wrote, AI is no longer just a story of what's possible. It's a story of what's happening now.
That's such a powerful statement, and it really encapsulates where we are in the AI journey. This isn't speculative future tech anymore. It's actively reshaping industries, governments, and daily life right now.
And the report has expanded its scope this year to include new analyses on hardware trends, inference costs, corporate responsibility, and AI's growing role in scientific research and medicine. This gives us an even more detailed picture of how AI is evolving.
What I appreciate about Stanford's approach is how data driven it is. In a field that can sometimes be dominated by hype and speculation, having this kind of rigorous fact based assessment is incredibly valuable for policymakers, business leaders, and the public.
Absolutely. The report has become so authoritative that it's regularly cited by major media outlets and referenced by global institutions. Companies like IBM, Accenture, and Wells Fargo have been briefed on its findings. It really has become the definitive assessment of where AI stands globally. One of the most eye-opening revelations in the Stanford report is the dramatic improvement in AI performance benchmarks. These new models are shattering previous records at a pace that's honestly hard to comprehend.
The numbers are staggering, John. On newly established benchmarks like MMMU, GPQA, and SWE Bench, we're seeing performance jumps of up to 67 percentage points in just a single year. That's an extraordinary rate of improvement.
And in some cases, these language agents are now outperforming humans on programming tasks when there are time constraints. That's a significant milestone.
It really is. Behind these performance gains is another important trend: the plummeting cost of inference. According to the report, the inference cost of GPT 3.5 level performance has dropped by more than 280-fold in just 2 years. That's an astonishing rate of cost reduction.
The economics here are fascinating. We're seeing this virtuous cycle where increasingly efficient hardware, combined with more compact but equally capable models, is driving these costs down dramatically. It's reminiscent of Moore's law, but possibly even more accelerated.
Exactly. And these cost reductions are having real world implications. AI capabilities that were prohibitively expensive for most organizations just a couple of years ago are now accessible to much smaller companies and even individual developers.
I think that's a crucial point. The democratization of these powerful AI tools means we're likely to see innovation coming from unexpected places. It's not just the tech giants who can play in this space anymore.
And speaking of democratization, the report mentions how these efficiency gains are enabling edge deployment, running sophisticated AI models directly on devices rather than requiring cloud connections. That opens up entirely new use cases.
Right. When you can run these powerful models locally on a phone or IoT device, you address privacy concerns, reduce latency, and enable applications in areas with limited connectivity. It really broadens the potential impact.
One thing that struck me in the report was how quickly the performance gap between top models is narrowing. The difference between the number 1 and Thugger 10 models fell by more than half in just 1 year. That suggests we're entering a more competitive phase in AI development.
It indicates that the barrier to entry for producing state of the art AI is lowering, which should accelerate innovation even further. When you have more players able to compete at the highest level, you tend to see more rapid progress.
All of this has implications for mainstream AI adoption. As these systems become simultaneously more capable and less expensive to deploy, we're seeing adoption rates that would have seemed impossible just a few years ago.
I think what's particularly notable is how quickly this technology has moved from novelty to utility. Organizations aren't just experimenting with AI anymore, they're integrating it into their core business processes and seeing measurable returns on investment.
The sector by sector adoption rates tell an interesting story, too. Financial services and healthcare are leading the way, with retail and manufacturing showing the fastest growth in AI implementation. But even traditionally slower moving sectors like education and government are seeing substantial increases in AI deployment.
That's right. And the report highlights how this adoption is creating a kind of snowball effect. As more organizations in a sector successfully implement AI, their competitors feel increasing pressure to follow suit or risk falling behind.
We're also seeing significant differences in how AI is being adopted across company sizes. Large enterprises still lead in terms of sophisticated AI deployments, but the gap is narrowing as smaller companies gain access to more affordable AI tools and pre trained models.
It certainly feels like we're approaching an inflection point where AI becomes as fundamental to business operations as the internet or mobile technology. The report certainly supports that view with these remarkable adoption metrics. With such rapid adoption, governments around the world are scrambling to keep pace with appropriate regulation. According to the Stanford report, the US introduced 59 AI related regulations in 2024 alone, which is more than double what we saw in the previous year.
It's a significant shift in regulatory approach. After years of what we might call cautious engagement, we're seeing governments taking much more decisive action. The report noted that legislative references to AI rose over 21% globally last year.
And it's not just about regulation. Governments are putting serious money behind AI development. China launched a $47.5 billion chip fund specifically aimed at advancing their semiconductor capabilities for AI applications.
That's enormous, but still dwarfed by Saudi Arabia's initiative. They announced what they're calling Project Transcendence, a $100 billion investment in AI infrastructure and capabilities. Even Canada, which is a much smaller economy, has pledged $2.4 billion toward AI development.
These massive funding initiatives signal that AI is now viewed as critical national infrastructure, similar to how countries historically invested in railways, highways, or electricity grids. It's becoming a cornerstone of economic competitiveness.
However, the report also highlights a concerning gap between regulatory intent and enforcement mechanisms. While there are more AI regulations on the books, the actual infrastructure to enforce these rules remains underdeveloped in most countries.
Exactly. And when we look at responsible AI implementation, something that's frequently mentioned in policy documents, the reality is quite inconsistent across the industry. The report notes that formal safety evaluations are still rare, even among major AI companies.
That's troubling, especially since the report also documented an increase in AI related incidents and failures. There seems to be a disconnect between the growing regulatory attention and actual safety practices in the field.
I think part of the challenge is the pace of innovation versus the inherently slower process of regulation. By the time a particular AI capability is regulated, the technology has often moved several steps ahead.
And there's still significant variation in regulatory approaches between regions. The EU continues to pursue its more precautionary approach with the AI Act, while the US has favored a more sector specific regulatory framework, and China has implemented both strong support and strict controls.
The Stanford report also highlights an interesting trend in how AI is gaining recognition in traditional scientific fields. For the first time, we're seeing major scientific prizes acknowledging AI's contributions.
Yes, that was fascinating. The Nobel Prizes in both physics and chemistry specifically recognize contributions from deep learning and AI's role in protein folding advances. That's really a watershed moment for the field.
And let's not forget the Turing Award, which is essentially the Nobel Prize of Computer Science, recognized groundbreaking work in reinforcement learning. These accolades underscore how AI is no longer just a tool for science, but is actually helping reshape fundamental scientific discovery.
I think it shows a maturation of the field. AI isn't just a separate discipline anymore. It's becoming integrated into the fabric of how we conduct research across virtually all scientific domains.
Speaking of integration, the report had some really interesting data on public perception of AI across different countries. There seems to be a significant geographical divide in how AI is viewed.
That's right, countries like China and Indonesia show overwhelming optimism, with 83% and 80% of their populations respectively viewing AI as more beneficial than harmful. That's a strikingly positive outlook.
Meanwhile, in Western countries, we're seeing much more caution. The report shows only 39% of Americans and 40% of Canadians share that optimistic view. Though interestingly, those numbers are actually improving.
Yes, sentiment in several historically wary countries like France, Germany, and the UK improved by at least 8 percentage points over the previous year. So while skepticism remains, the trend is moving toward greater acceptance.
What I found particularly telling was the disconnect between increased adoption and persistent trust concerns. Even as people integrate more AI tools into their daily lives, concerns about data privacy, algorithmic fairness, and AI generated misinformation remain acute.
Exactly. The report specifically noted that confidence in companies to protect user data continues to erode, which creates this interesting paradox. People are using more AI tools while simultaneously becoming more worried about their implications.
I think that speaks to a broader tension we're seeing throughout society. The practical benefits of AI are becoming too significant to ignore, but the ethical frameworks and guardrails haven't fully caught up yet.
And that's probably why we're seeing this geographic split. In countries with different traditions around privacy, individual rights, and the role of technology in society, the risk benefit calculation plays out differently.
It reminds me that AI development isn't happening in a cultural vacuum. These systems are being built within specific societal contexts that shape how they're perceived and what concerns rise to the top. Another critical area the Stanford report examines is AI education and access worldwide. The numbers show some encouraging progress, with K-12 computer science curricula now including AI in two-thirds of countries.
That's more than double what it was in 2019, which is a pretty rapid integration. And in the US specifically, the number of computer science graduates has grown by 22% over the past decade. These are positive indicators that the educational system is responding to the AI revolution.
But behind those numbers, there are some significant disparities that we can't overlook. The report makes it clear that global access to AI education remains highly uneven, especially in parts of Africa where basic infrastructure gaps persist.
Right, and even in developed countries where resources are more plentiful, there's still a major challenge with teacher preparedness. The report mentioned that while 81% of US computer science teachers believe AI should be part of foundational education, less than half actually feel equipped to teach it.
That's a huge gap between intention and capability. We're essentially asking teachers to prepare students for an AI powered future when many of those teachers haven't received adequate training themselves.
It reminds me of the early days of general computing education. There was a similar lag between recognizing the importance of computer literacy and actually having enough qualified instructors to teach it effectively.
And the stakes are arguably even higher now. This isn't just about technical skills, it's about preparing students to think critically about AI systems that are making increasingly important decisions in society.
Exactly. Without proper education, we risk creating new forms of digital divide. Those who understand AI and can harness or critique it, and those who are merely subject to it without comprehension.
The report also highlighted something interesting about the pipeline problem. Even as we see growth in computer science graduates overall, the diversity challenges persist. Women and underrepresented minorities remain significantly underrepresented in AI related fields.
Which then becomes a cyclical problem. The AI systems being built reflect the perspectives and priorities of their creators, so limited diversity in education eventually translates to limitations in the technology itself.
Looking at these three major stories we've covered today, Meta's Llama 4 models, IBM's acquisition of Hakkoda, and Stanford's comprehensive AI index report, I'm seeing some fascinating patterns emerge about where the industry is headed.
Absolutely. One clear thread running through all three stories is the continued dominance of big tech and industry players in advancing AI. The Stanford report specifically noted that nearly 90% of top AI models in 2024 came from industry, up from 60% the previous year.
That's a dramatic shift in just 12 months. And we're seeing that play out in real time with Meta's massive investment in those 350,000 NVIDIA H100 chips, far outpacing what competitors like OpenAI and xAI have at their disposal.
At the same time, though, the competitive landscape appears to be tightening. The Stanford report mentioned that the performance gap between the number 1 and number 10 AI models fell by more than half in just 1 year. So while the big players are dominating, the technical advantages between them seem to be narrowing.
That's a great point. Meta's open source approach with Llama 4 feels like an acknowledgement of this reality. They're betting that widespread adoption and integration across third party platforms might be more valuable than keeping their technology proprietary.
Meanwhile, IBM's acquisition of Hakkoda points to another major trend: the growing recognition that data readiness is the critical foundation for AI implementation. All these spectacular models don't matter much if organizations can't properly prepare their data estates.
Exactly. It's not just about having the most powerful models anymore. It's increasingly about who can help enterprises actually implement AI effectively across their operations. That's why that projected growth to $243 billion for enterprise intelligence services by 2028 is so significant.
I also see a connection between Meta's mixture of experts approach in their Llama models and the broader efficiency gains the Stanford report highlighted. The inference cost of GPT 3.5 level performance dropping 280 fold in just 2 years is remarkable. We're seeing AI become simultaneously more powerful and more efficient.
And that efficiency is what's going to drive the next wave of adoption. As these models become more affordable to run, we'll see AI capabilities showing up in more products, more services, and more industries. Exactly what the Stanford report showed with those adoption metrics climbing across sectors.
But the social and regulatory challenges are growing in parallel with the technology. All three stories touched on this tension between rapid technical progress and the human system struggling to keep pace, whether it's public trust issues, regulatory frameworks still taking shape, or educational systems playing catch up.
That's going to be the defining dynamic of AI development for the foreseeable future. This race between exponential technical capability and our much slower human institutions trying to ensure the technology develops responsibly. Well, Gladys, we've covered a lot of ground today, from Meta's ambitious Llama 4 models to IBM's strategic acquisition of Hakkoda and that eye opening Stanford AI Index report.
It's been fascinating to see how these stories paint a picture of an AI landscape that's evolving at breakneck speed. The technical capabilities are advancing exponentially, while adoption across industries continues to accelerate.
What really stands out to me is how AI is no longer just a future promise. It's actively reshaping business operations, scientific research, and even everyday consumer experiences right now.
Absolutely. And I think listeners should keep an eye on how these different threads we've discussed today continue to develop, especially the tension between open source and proprietary approaches, and how regulatory frameworks evolve to address both innovation and safety.
Looking ahead to future episodes, we'll be tracking developments in AI regulation, particularly as the US and EU take different approaches to governance. We're also planning to explore the emerging field of AI agents and their potential to transform knowledge work.
And of course, we'll continue monitoring how these powerful new models are being deployed in critical sectors like healthcare, finance, and education.
That's right. Until then, thanks for joining us for this edition of the Pure AI Podcast. I'm John K. Waters.
And I'm Gladys Rama. If you enjoyed today's episode, please subscribe, leave a review, and share with colleagues interested in the rapidly evolving world of artificial intelligence.
We'll be back next time with more insights and analysis on the latest developments in AI. Until then, stay curious.